All right, welcome to the session. My name is Akshay Gupta, and we're going to talk about process manufacturing today. I've got a few co-presenters with me. We'll have EOS, a partner who works with us in the TAP program, present implementation that they have done at a company called EAS. So the partner is EOS and the customer is EAS. And I've got my colleagues here who will help you around with the microphone if you have any questions. So feel free to stop me whenever you wish to ask a question. We'll try to stick to the time because there's a session on distribution for process manufacturing immediately following this session. So we'll try to kind of finish this in time so we can go to the other room and set up the next session. Okay. So this is the disclaimer before we start. It's a pre-release software, and basically, you've seen this all the time. Okay. Now, what we want to show today, how you can enhance supply chain visibility by using Dynamics AX 2012 with an enterprise with many legal entities. I think you've seen this in the beginning of the conference. In the first manufacturing session, Ulrich covered some part of it. And we've got some more data on this in the process manufacturing data set. So we'll just show about 2 minutes of this. And then we'll talk about specific to process manufacturing, all the features that are there, and how you can reduce costs by accurately calculating the cost of producing many products at the same time, which means co-products. And by ensuring how excess bulk that is being produced is packed into goods which move faster than the others. Right, so that's the bulk pack scenario. And we've done a lot of work around formula maintenance. So we've had a lot of complaints in the previous version. So we've done plenty of work, and we'll share with you the work that we've done. And the last part is this is where the partner will come in and show how they have used the process manufacturing feature set in a discrete environment. Okay, so we believe that having a good data set is very important for channel, for pre-sales and so on, because it makes it easier to, especially for an industry solution, it makes it much easier if you have industry-specific data set already set up in the system. So we'll release this data set when the solution releases. So this, we'll spend about 2 minutes on this to show how the data set is, because it's also used in the demos. So we've got a company called CCT, and this is a chemicals company, Contoso Chemicals Taiwan. And it's got 2 sites. One of the sites makes some chemicals, and the other site makes paints. Then we've got another company, which is called Contoso Plastics. It's based in China. And they have 3 sites. The first site makes some polypropylene plastics. Next site makes some polyvinyl chloride plastics. And the last site is basically molding the PP plastics that you have into various compounds. And then this site, this company, people who are in the TAP program and have seen the data set must be familiar with. This is the Contoso Entertainment Company, which is the electronics assembly. And then last, we have a Contoso Foods company. So basically, these 2 companies are about chemicals, plastics. So for chemical vertical, the last one is for the food vertical. And we'll set up a company for pharmaceutical in the next few months before the data releases. So in this company, we've got 3 sites. There's poultry processing on one side, then there's bakery, and then there are desserts. Okay. Now, how the data moves is basically, so chemicals are used to make paints, and chemicals are also used to make plastics. And we'll see that example. And then these paints also go into electronics assembly. And then we have the plastics which are made, they come down to be molded into various things. And then the molds go to electronics assembly. Okay, so just remember CCT and CPC. We'll see an example about this just in a while. So this one also you must have seen, people who have attended the first manufacturing session. So it's basically putting the companies differently. So you have Contoso Chemicals here, Plastics here, and the Electronics Assembly Company here. And now basically here I'm taking an example specifically to explain how these companies are related in the data set. So for instance, if you make car speakers, you assemble them using lean assembly. But to make car speakers, you need some car speaker covers. And those car speaker covers get produced here. The color is indicating that these are production orders. And then you need some plastic to make these car speaker covers. So that plastic is coming out of the Contoso Plastics Company, and that is a batch order. Okay, and then to make the plastic, you need some chemicals, which is again a batch order, which is coming out of a different company. Okay, so that's a scenario which will be set up, which is already set up, and we'll build more on this scenario when the data set releases. So basically, you can use all these three companies to set up various scenarios. Okay, just a quick show of hands. How many of you have already worked with or seen process manufacturing solution in different? Excellent. So I don't have to go into too much detail then of the previous feature set. Okay. So I think, yeah. So I'll go back and show you an example in the system now. So that's a planned order screen. And that's an item, which is the car speaker cover that I showed in the previous screen. So basically what you can see here is that if you go to the planned order for car speaker cover, notice this CPC, that's the addition. That means Contoso Plastics. So Contoso Plastics needs to create a planned production order. And if I click on further, then basically this production order that has to be created is coming out of a batch order here. All right, so you make batch orders, you supply something, then you create a planned order to make that car speaker cover. Now this is all CPC, so there's no intercompany until now. But actually some of these, for instance, this item here, this is a chemical. And this chemical is coming from the chemicals company. Well, it used to come. Hold on. Let's try this one. Let's try this one. Okay. So this one is coming from a chemicals company. And here you can see the first three characters change in CCT. So basically, what this example is showing is that this improves supply chain visibility, right? You are looking at one company and you can see across in different companies where the orders are coming from and how the supply is getting fulfilled. So we're going to get all the purchase orders for these items, then make a batch order for this item, which is a chemical, and then purchase that batch or purchase that chemical into CPC. Okay? And then from there on, it goes further in the process. So that was the short example which I wanted to give because we had more data set to show how you can use that in if you have multiple companies set up in the enterprise. Okay? I'll go back to the presentation and talk about the process-specific features. Okay. So pains and challenges. Now, in the previous versions of AX, this is what we've been told. The pains have been that you need to create multiple formula. Whenever the formula size is different, then you need many formulas to maintain and it becomes very difficult. And also you don't have any facility to model nonlinear consumption, which is quite common in food and chemicals. And if you want to model that, basically you will have to create a lot of formulas to be able to do that. Then the other one is changing ingredient item consumption. Now this does not scale the formula size, even though the scalability is supposed to work, but there were some problems with that. So we've modified that and it works now. The other problem that we've come across is that it's difficult to it's difficult to maintain the formulas in the sense the control on the formulas. Like if you have a master formula and then you have several formulas which are being in different stages of creation, and you have certain other formulas which are already fixed and everybody just goes and produces according to those formulas. So there are different kinds of formula you can have, and there is no control in AX as to how you will which formulas to use and which formulas should not be allowed to be changed. So there were a few problems there, and I'll show you how we have come across that problem and solve that. Okay, then on the shop floor side, as you know, shop floor is called manufacturing execution now. So manufacturing execution, it was not possible to do any manufacturing execution or shop floor recording on batch orders. And same thing applies for catch weight items. Since many of you already know process manufacturing, I'll just use the term catch weight, assuming everybody knows what that is. So it was not possible to do any catch weight recording in the previous versions. Then coming to Eduardo, the production planner, again, what the problem we found here is that on the plan orders, if you combine a few plan orders into one big plan order or split a plan order into different, then the system will pick up any version. It doesn't pick up a version which is approved and active. So this was again a problem that we received because the control of formulas and versions is much more stricter in a process environment. Therefore, we've made that work now. Yeah, and there were some other problems on the production side. Yeah, so this one I've already talked about. The Shannon, she can do data recording now if you use manufacturing execution together with process manufacturing. So a little bit more in a process flow format on what we have changed. So basically, this is a simpler flow, just showing the personas on the left and the process flow. So you create products, create a formula, approve the formula, then go and create some planned orders, create batch orders out of that, and then do some shop floor recording on that. Now, basically, what have we changed here? So these are really, I mean, this is just getting warmed up, as in these things that pop up here are not the only things that we have changed. So on the product side, there is we've introduced something which was kind of already there, but basically there's something called production type now, and that production type determines whether the item that is being produced is a co-product or a byproduct, or if it's a bill of material or a formula item, or if it's a planning item. Then catch weight products, you can now, since we have the concept of products, using process manufacturing, you can create a product and call it a catch weight product globally. So a product has to be declared globally if it is a catch weight product, because we don't anticipate customers having scenarios where a product is a catch weight in one company and a non-catch weight in another company. So you have to globally declare that, and then you can release it. Default order setting, basically this is kind of an uptake for us. And basically what this does is that it determines whether you need a purchased order or a production order to fulfill the supply. So you don't have to mark an item as having to be always produced or purchased. You can do this on at runtime, for instance. Okay, so approved formula, like I talked about this. So how do you control the formula better so that master formula cannot be changed and the other formulas can still be changed? So there was a parameter in previous versions of AX, but was not being utilized properly, and that parameter is called block editing. I'll show you that. Basically, if you mark this parameter on the inventory management parameters, then all the formulas that are approved and all the versions that are approved, they cannot be modified. And there's one more level to that, and we'll talk about that in the demo. On the planned orders, basically that's one of the key changes we've done on the planned orders, to make sure that the formula that is being picked up and the version that is being picked up for manufacturing, when you combine planned orders or split planned orders, is the approved and active version. This changes on the cost allocation or cost calculation for co-products and byproducts in the batch order. and I'll talk about this in the demo. And then there is change on the shop floor recording, right? So shop floor can be used, or manufacturing execution can be used together with batch orders to do catch weight recording and to record multiple outputs. Any questions? No? Okay. So this is an industry-specific application, and that's where we're going to talk about process manufacturing production. Okay, so these are the demos that we have. We don't need to read all of those, but let's just get into the first one. Okay, I have to, right. So there is a little bit more detail here than the previous one. So what we do here is, I'll talk a bit about what we have changed in the formula. So the first thing is this one, lines are controlled by version. Basically what this means is that you're not allowed to enter formula lines until you have created a formula version. On the bill of material, it's pretty open. You can create lines without a version. You can create a version without lines. And you can basically have a bill of material which is approved without any lines. But all that is more controlled in formula. Then there is a concept called step consumption, and this is to be able to model nonlinear consumption. And the example is usually if you use 1 egg to make 100 grams of cake, how many eggs do you need to make 150 grams of cake? Right. So basically, you can use the step consumption for that. Okay. Then scalable. We've improved the scalable functionality, and well, we don't need to spend too much time on that. Okay. And then the other thing is you can have many formula versions. In the previous version of Process Industries, you could not have more than one version if the formula size was different, because formula size was stamped onto all the formula lines and the co-byproduct lines. So we've kind of freed that up so that the basic idea, the basic driving factor for all these changes is it should be very easy to set up formula and to use with formulas, and then the last one is also similar, copying facility on co-by lines. In the previous versions, we had to enter co-by lines one by one, and co-by lines are tied to the formula version, which basically means that if you have 10 versions, then you'll have to enter all the co-products and byproducts for each version one by one manually. It's a lot of work. Block editing. So, okay. Well, I'll go to the demo and try to show something. So let's take this formula and spend a few minutes on this. Right. So this formula is for making a box of chicken legs. Yep. So basically, we have a tray of chicken legs. I don't know, and you can see, the catch weight quantity here, 10 each. So which means there are 10 trays going into this formula, and each tray weighs about 1.1 kilos. So that's basically, this is a formula which is showing use of catch weight in the ingredients, and also showing use of catch weight on the formula version. As you can see, the final product that is being made is also dual unit of measure or a catch weight item. So it's a 10 kilo box. And if you look at the co-products, oh, there are no co-products here. Well, let's go to another one. Okay. Well, this is a formula from the UK foods company, and this is being used to make front half of boneless, skinless chicken breasts. Okay. So basically what it is showing here is all the changes that we have done. And for instance, I'll talk a little bit about total cost of allocation, which I'll talk in the next demo. What I want to show here is all these items and the fact that it can be controlled by block editing. So now if I go to the inventory parameters, and here you will see these two flags, block editing and block removal of approval. So if I click block editing here, and go back to the formula, any formula, I cannot do any editing anymore. Okay? Same thing goes on co-products. It's all locked. Because that's a master formula, and you don't want anybody to go around and changing master formulas in the system. If it's not a master formula, then you don't approve it. So for instance, now if I look at this one, and if I remove approval from the version, it's open for change. Okay? So basically anything that is approved cannot be changed once you turn that flag on. The other thing is that the other flag is called block removal of approval. What this means is that you're not even allowed to remove approval. So this is next level of control. So here I don't have remove approval check mark anymore. I cannot, even though this formula, here you can see this is approved, I cannot remove approval. Okay? So there are different levels of control. One is block editing. The next one is block removal of approval. And the last one, if you want even more control or somewhere in between, you can use the e-signature. Right? I've not set it up, but I can still show you how to do that. Where was that? Is it here? Yeah. So what you do is that you just go in here and create a new record. If you want to prevent, for instance, this one. So this one is basically preventing change on the yield field, on the yield. So you don't want anybody to go around and change the yield that you have set up after a lot of work on that particular formula, right? Yield is usually set after you spend a lot of time looking at the formula and making what's being produced and calculating. Then you set up yield and somebody goes and modifies that. So if you want to prevent that, then you can basically set that up here. You just have to find the yield field. I think it's called that. And then you can say, when do you want to ask for a signature? When a record is updated, record is deleted, or a record is inserted. Okay, once you do that, then basically anybody who changes any particular field, this is all across the application. It's got nothing to do with formulas. It's got nothing to do with process manufacturing, but it just allows you to add another level of control. Okay? All right. So some more things which I can show on the demo or show it like this here. But I think I will skip this since most of the people already have worked with process manufacturing. What this is saying is that on the versions you can set up catch bit size and from catch bit size. And you can also set up catch bit unit. You can set up formula size and from formula size. These are all fields which have been added on process manufacturing module. And co-product variations and total cost allocation and bulk item. Step consumption. We can spend a few minutes talking about how to set this up. So if I go to a formula, let's go to another company. Let's take the chemicals company. So what you can do here is that you've got a, now this is a formula size, this is a formula for a formula size of 3,400 liters. So you're getting 3,400 liters of this chemical in the end, right? And what it uses is some more chemicals. And it also has some co-products and byproducts. Now, how to use step consumption? On the ingredients, okay, so on the ingredients, oh, luckily I found the formula which I've already set up, which is good. Here you have to, usually this is standard, but now you choose step. And when you choose step, then what it does is it makes these fields here for step consumption editable. It's adding some extra lines here, don't worry about those. Okay, so what it is telling is that if the from series is between 0 and 3,400, then the ingredient quantity that is required is 1,300. Okay? If it is more than 3,401, then there is some other quantity required. If it's more than 4,000, then there is some other quantity required. So it's kind of step consumption. Right? And you can build more on this and add more formulas if you want to, but really what it allows you to do is do nonlinear consumption. You could have done this using standard formulas, but then you will, just to do those three things here, you will need 3 different versions. Right. So now when you create a batch order, if you create a batch order for 4,000 units, right? In the standard system, it'll take a per series of 3,600 and then calculate, so what is required for 4,000, and then you will get a planned purchase order for that much. But if you use this, then it will use 1,600 because that's what you mentioned. So it's kind of fixed for a certain level, right? So if you have 150 grams of cake, you still need 2 eggs, maybe, right? Okay. So that's really what it does. Now, block editing and block removal of approval and use e-signature. I think we've talked about this already. So basically, I didn't show scalability. Co-by copy is basically just copy of the form, so there's no point spending time on that. But what we can do with the new formula, whatever you have seen a little bit of it, is that you can create multiple versions, which was not possible before. You can copy co-by lines, which you have to trust me that you can, because I didn't show that. And that the formula size scales with the change in the ingredient quantity. and the ingredient quantity will also change with the change in formula size. Scalability works both ways. And it's much easier to maintain the formula. And then this part, block editing and block removal of control, we believe this gives you much more control over your formulas and versions. Okay? Next one is, let's talk a little bit about batch orders. So among a few things which have changed on the batch orders is the way calculation is done. There's something called burden amount, which is on the byproducts. Burden amount is the amount that you have to spend to get rid of the byproduct that is being produced. Now, in the previous versions, we just had a fixed burden amount, right? So we set that up in the formula and say that, okay, whatever is being produced out of this formula, to get rid of that, you would have to spend $5. And there was not too much flexibility around that. So we've introduced a little bit more flexibility. We've got a few more options to set up burden in different ways. And there's something called total cost allocation now. And total cost allocation is taking weighted average for co-products. And I'll talk a little bit more about how it is taken. Co-product variations, this is existed in previous version as well, but I put in here because that works together with total cost of allocation. So if you have items being produced which you did not expect to be produced, then the costing should take into account of that. So the new changes in the costing are such that they will also take into account of the variations that are being done at the stage of production. Okay. Okay. Well, we don't need to go into the depth of this, but co-product cost. I think I need to explain the simple thing, what has changed. So this yellow part is the previous version, and the green part is the new version. Okay. So imagine that you're getting two co-products out of the formula. Right? Co-product A and B. In the past, you could set up a cost allocation person. You could say that whatever is the cost of producing this order, you will allocate 30% of the cost to co-product A and 70% to co-product B. And then you would have some quantity on the formula, which basically is saying that 4 units of A is coming out and 6 units of B is coming out. And system didn't take into account the current active cost price of these co-products for calculating the cost allocation. And what it would, so it would look at what's the total production cost. Total production cost, let's assume it's $100 of making whatever you're making out of this batch order. And then it'll say, okay, 30% of $100 is $30 and $70. That's what it'll calculate on the formula. Right? That's a simple calculation. It worked. But now what it does is, it's a little more smarter than that. It'll calculate something like cost amount, which is basically taking into account what is the cost price of each of those co-products. Because the cost calculation needs to take into account what is the value of, what's the difference in the value of the two items that are coming out. Doing this assumes that the value is same for those two. But actually, we know that in the system there are cost prices. So now it uses those cost prices, and it says that, okay, takes an average. So it says $4 total cost of the co-products is $28. So it divides 4 by 28, and the rest is here. So that becomes your cost allocated percentage. All right, so that's sort of taking the quantity that is coming out and taking the active cost price into consideration. And then this is basically just multiplying it by the total cost of the batch order, right? So this would be the cost that is allocated to co-product A, and this is the cost allocated to co-product B. But this is at the formula level. When you produce a batch order, then this all will scale. Because then this is not 4 or 6. This would be something completely different depending on the batch order. Right, so whatever that is, it'll scale using this. That's the second level of complexity, if you want to call it. And then the third is if you have variations. So you wanted, in the formula you set up A and B, and now if you get C and D as well. So whatever is the report is finished quantity on those C and D, it'll take the active cost price of C and D, and it'll take the total $100 into A, B, C, and D, and then divide equally. Not equally, divide based on that ratio. Okay? So that's the co-product cost allocation change. On the byproduct side, what we had in the previous version was a fixed percent, a percent or a dollar amount. And if it was a dollar amount, it will add that dollar amount to the total cost of production. If it was a percent, then it will just give that percent, calculate what is the percent of the allocation to the burden amount, and add that to the total batch order cost. But now you can do two more things to that. You can do something called per series, and then you can do something called per quantity, depending on how you set up in the formula. What per series does is that it takes into account the batch order size. So this percent was also scaling in the past as well, depending on the batch order size. I need to check what this does. I'll come back to this.
Has to do with the parent.
Sorry?
How many of the parent?
How many of?
Of the parent.
Yeah, but that it was doing in the past as well. I need to check. I'll come back to you. What per quantity does, this was never available. What this does is that it actually looks at the actual report as finished for the burden amount as well. It used to do that for the co-product amount, but not for the byproduct. So we believe all these changes on the cost allocation will allow you to get more accurate costs, and you will possibly not have to do as many inventory adjustments as in the past. Okay? Well, I need to show this demo a little bit. So if I go to this formula, oh, not here. I think I need to change my company. So I'll go to the chicken processing company because it has much more interesting co and byproducts. So these are all the co-products. You can see this is the rear half of the chicken, and these are breast fillets. And then there's some wings and tenderloins, and then some byproducts. And what you need to do to run total cost allocation is that you need to have this flag tick marked. This one is saying that you want this version, any co-products on this version, you want them to be total cost, use total cost allocation. So you still have flexibility if you want to use the previous system. Now, once you do that, then here you can see that this is the same field that we had in the past. Total cost allocation is 15%, 20%, 25, 10, whatever, right? And in the past, it will just take and divide the cost based on that percentage. But now what you could do is, there's a little button here, which is called estimate cost. This is still on the formula level. After you have set up the formula, you can click this, and then it'll show you. It's basically showing exactly the same thing that I just showed on the other simple examples. So all these, it only picks up the co-products from there, has catch weight quantities, and it has the inventory quantities, and then it's picking up the active cost price from the system, and then it's doing that calculation, and then it's coming up with this percentage. So using this, at the time of creating formula itself, you have much better control. Because now you know, you will look at this and you will think, Wow. Making rear halves is almost half of the cost of making the whole thing. Is this right or not? Right, so otherwise you would have to manually input the cost allocation and then you don't have much control over it. Okay? So this is at the formula level, and then on the batch order also, once you create a batch order, you can use the same and see what the estimation will be. Okay, on the burden, like I said, we had none and percent, only these two possibilities in the past. Now you have per series and per quantity as well. Okay, so this is really where you set up different levels of burden, how you want the burden cost to be allocated, or how do you want the batch order costs to be determined by the burden amount. That's a standard error message. There's probably, because it's a planning item, so I need to allocate it completely. Okay. Any questions? All right. Let's move to next item. Bulk and pack. Now, there were a few problems. This came out in the very last version of Process Industries. It was not there in the previous versions. So I'll explain a little bit on. Well, I think I've got a slide where I can explain that a little bit more. So it's basically making of bulk orders and pack orders, and it's something to do with something called make quantity. Okay. There's more description here. So what's a bulk item? This example uses bulk item as a bulk paint item. Could be anything else. Could be a bulk chemical. And pack item is an item which is, so bulk item is being packed into different packages. That's really the concept. And you want all these bulk orders and pack orders to flow together all the time. Because if you have many pack orders, as in this example, and there is no connection between the bulk and pack, then it's very difficult for the gentleman in the previous slide, this guy. So how you do this is basically what this screen is showing is that you set up a conversion between the bulk item and the pack item. Until what time is this session? Okay, and what you do here is that I've got an example here. That's better to see this one. Now, so we've got these different pack items, and all of them get this bulk item. Okay. Now the first pack item is 10 cans of 1 liter paint packed in a box. The next pack item is 5 cans of 2 liter paint packed in a box. And then third is 2 cans of 5 liter paint packed in a box. And then this is a barrel of 15 liter paint. And there's a drum of 20 liter paint. So these are all different pack items. Right? If you don't keep track of these together with the bulk, then it's very, very difficult in a plant which processes this stuff. So what you will likely get in this example is you get a requirement for the pack item. So customer comes and tells you that I want 100 boxes of each of these. Well, this can't be boxes. These are probably 100 barrels and 100 drums. And then with the help of this conversion, what you will find is that there are 10 cans of 1 liter, and if you want 100 boxes, that means you want 1,000 liter of paint. Right? So you want 1,000 liter of paint, 1,000 liter of the bulk item to pack in this one. Then you want another 1,000 liter to pack in this one, and so on. Okay? So basically, if you have a sales order requirement which is asking for all these pack items, then you want a way to be able to determine how much should be the bulk that needs to be produced. And then you want to create a bulk batch order, and you need to create many batch orders for all these pack items. Then you want to keep them in sync, and you want to make sure that all the material goes together. So that's what was introduced in the last version of process industries. But what we made some changes to this to make sure that the pegging is correct all the time, because you want to make sure that this requirement for these pack orders is tied to the sales order from where this comes. So it gets messy when you have a lot of these requirements matching up with the bulk. I'll show you an example where you can combine the bulk order that is being produced and the pack orders that are being produced and put them together into something called a consolidated order or consolidated batch order. The other change that becomes important here is that this is a very simple example that you just add 1,000, you get 6,500. But what will happen is that sometimes you will have some standard order quantities on some of these items. You'll have minimum order quantities on some of those items and so on. And then what you might find is that even though ideally you would like to produce like this, but because of whatever constraints in the production you cannot. So you might end up producing 10,000 liters or 5,000 liters. And when that happens, then that's where the make quantity gets useful. Because then what you will do is system will provide you a little bit support in that. And using that, you will be able to put those extra, let's say you make 10,000, you will be able to decide where to put extra 3,500. Because you want to put 3,500 into the boxes which sell the fastest, which move the fastest. All right? You don't want to, if the drums are not getting picked up, you don't want to keep making extra drums for all the extra quantity that you're making. So that's the change. Okay. Do a demo, short demo on this one. So I've got a sales order here, which is actually asking for 1,000 boxes. I think there's another one. There's a sales order here which is the same as we just saw in the example. So it's asking for 100 boxes of all of these items. Okay. And then basically once you run master planning, what you will see is that you will get planned batch orders for all these items which need to be packed. Don't look at the ones which are 1,000 in them because they are for another sales order. So those are all the packed items. So planned batch orders for all the packed items. And then you will get planned batch orders for all the bulk items. And then what you need to do is something called firm and consolidate. All right. Let's try again. One more try and then we'll give up. Let's try once. Okay, so I've selected all my bulk and pack together. And what I get here is something called a consolidated batch order. This form needs a UX refresh and it'll get it by the time we ship. But now here you see all the packed orders. Right? And over there you see all the bulk orders. And usually you will have some standard order quantity, min and max order quantity for all the packed items, which will come up there. So what we are trying to do here is basically just putting these orders together. The screen is cut off, so I can't show you all the items there. But really, what will happen is that if I click this one, that's a consolidated batch order. It's a consolidation of all these bulk and all these pack. So you don't need to worry about all these individual orders after this. You just need to look at the consolidated batch order, and everything will work in the background by itself. Yeah?
Time. I think we've spent 50 minutes now.
Okay. Thank you. And if I hit the firm button here, that will basically firm the consolidated batch order. I'll not hit it right now. But the idea is that all these batch orders get consolidated together, and then you can use them together. Okay? And there is this make quantity which I talked about. In case of conflict, you need to change this make quantity manually, and that will determine which items you want to actually pack. Because right now this is picking up from the sales order. And you need to, if the standard order and min order quantities are such that you need to either make more or less, then you need to decide where to pack them. And system helps you a little bit in that. But basically, that's the quantity that you will change, and then you'll hit firm, and then you'll get the pack orders and bulk orders for that. And once you do that, then the system will still maintain the pegging in the background. Because even though you have changed the quantities here, the pegging needs to be maintained. Okay? All right. So, yeah, it helps. We believe the benefit is improves accounting of goods with correct production costs, and we've seen all of that. So I'll move on to the next one. Production control. How can Shannon use batch orders to record feedback on the shop floor? So what you can do is you can do catch weight recording. So if you have dual unit of measure, in the past you could not use manufacturing execution together with batch orders. That's the biggest change. Now you can use that, and you can do catch weight recording. When you do catch weight recording, then it is a little bit more complex, but now system handles it. And then the other thing is that if you're making co-products and byproducts, then that means you're making several items output, and the standard manufacturing execution will not handle that. But with AX 2012, it is possible to do that. And the last is that you have access to quality orders, which is very important in a process scenario, that when you're recording data on the shop floor, there might be quality orders connected to those production orders, and you want to make sure that you can see them, or Shannon can see them from the production floor as well. So that's what we can do. And how much time I have?
I think you have 55 minutes.
Okay. Okay. So, well, I'll go through this very quickly and then do a short demo on this. So you can start the batch order with catch weight quantity. You can report feedback on the jobs in catch weight quantity. You can end your batch order jobs, report multiple co and byproducts as finished, view open quality orders, view connected consolidated batch orders. And of course, if you're using manufacturing execution, you have some shop floor personnel and you want to record payroll data for them. And you can do that just by the nature of using manufacturing execution and time and attendance. I'll switch to the demo. Yes. Go away. So I'll go back to the foods company to show a catch weight example. So now we are in the manufacturing execution module. And we are going to one of the resources. And one of the Shannons is going to log on to this particular resource and see what are the open jobs for her. Ooh. Okay. One second. I think I need to create a new production order. So I'm creating a new production order. It's estimated, and then I'll release it. Once the production order is released, it's available on the shop floor for recording, for data collection. So now this is released, and now we'll go back into the shop floor module. So again, we go back to that resource, and we open the terminal on the resource, or rather the Shannon at the resource opens the terminal and does job registration. Okay, we just created that order, right? Number 17 is the order that we created, and that's the resource that we want to start working on. That's the first operation, and that's the resource which is being used for that particular operation. So what we will do is, now first thing you will notice the difference from the past is that you have the catch weight quantities. You have the possibility to record catch weight quantities here. Okay? So I will say I want to start 10 boxes of whatever. Okay? So you're not entering the inventory quantity. You can enter if you wish to, but you're entering that you're starting whatever you have to start. You're starting 10 boxes of it. And then you just click Start Jobs. Okay, so this guy. All right. I need 1 more minute to demo this. We'll create a new worker. Let's take one. So now we are hiring a new person. Because everybody is busy doing something else, we need more people. And then we need to give them a badge ID. Let's see. Okay, let's go in and sign in as 007 on the same resource. That's okay. Sign in again. All right, so I've got this. This is the one that I want to start. So I will say I'm starting 10 boxes of this. Okay? I click on Start Jobs. And you are now successfully clocked in. Right? So when this message comes in, that means 007 has started working on this particular operation. And now they are packing 10, or he's or she's packing 10 boxes of something. Basically, the demo is to show you that manufacturing execution works with process manufacturing, and you can do catch weight recording. Okay? All right. That's the pick list, which you can post any other time. So. All right, so same thing again. Data collection can be done. Okay. With that, I'll invite Roberto on
Many
stage.
Thanks, Axel.
Yeah.
How can... So I would like to explain, to share with you our point of view through an example of the use of process manufacturing in a discrete manufacturing environment. Mainly, we operate in discrete manufacturing and have experienced the process manufacturing like a vertical, but sometimes also as a set of powerful features also for this kind of context. The presentation explains a real case of a real customer we are working on in early adoption with the AX 2012. Yes. Actually, sorry. How can we move forward with the slide? Sorry. EAS is a discrete manufacturer that produces high-tech electronic board with a design-to-order process mainly. This design-to-order product is designed and projected based according with the customer specification and constraints. This kind of board uses a lot of components that are very critical because of logistic issues, because of pricing issues, and because of the obsolescence. We have used in this kind of industry a lot of features from process industry, process manufacturing, like, for instance, the vendor-approved list, like the lot management for through expiration date. But the main issue we have addressed in this kind of environment are mainly using the alternative items and the co-product management. Alternative items because they have finished good that assemble components for which the customer publish a specific vendor approval list. So for the same finished good, they can use a lot of alternative components certified by the customer. Different product could have different alternative vendor approved list. So we have used the item substitution to explain in the bill of material all the possible alternative items, leaving the planning system to use the availability of them during their plan cycle. The second issue we address with process manufacturing is the co-product. They have a lot of board that have a common process at the first stage to assemble component in the same motherboard that just in the final stage of the production will be cut, generating a lot of different finished good. This is the context we have addressed with this kind of feature of process manufacturing, taking just functionalities and introducing in this kind of environment. I leave my colleague to demonstrate this one.
Okay. This is backward?
Yeah, and this is forward.
Okay. So the first issue we addressed using the process manufacturing is the alternative item issue. It means that we have the customer telling EAS which supplier has to use to procure a component for their board. So we have two kind of situation. We have a situation where the component has to be purchased only from one vendor. So we have an example of a resistor where the vendor, the mandatory vendor requested by the customer is Vishay, and the other situation, the other scenario is an optional, which is in our example is an integrated circuit where our customers requested us to purchase only from a list of vendors, ST, Samsung, and Philips. So in this scenario, we addressed the problem using two features of process manufacturing called plan groups and priorities. So what we are going to see in the next demo is how we classified the items in the formula in order to address this problem. So here we can see that the product designer create products, create components called approvals because they are approved by customer. The customer is telling us the vendor, and then we create a formula, approved formula, and in the formula we have the plan groups grouping the alternative vendors, the components with alternative vendors, and then finally when we create the planned order, all the planned order are created according to availability and approval priority. So the highest priority means that we have to purchase that component. So we switch. Yeah. Okay. Okay. It's my fault. That's my fault. Solution. Okay. Yeah.
Now you can see here.
Okay. So this is my resides.
So the demo is on the AX6 version because they're partner with us, and they're using, well, it's a part of the customer data set.
Yes, of course.
Okay. So the example I was describing you is represented by this item here, and we have this item composed of a list of components, and we have a fixed component from Vishay, and we have this is the resistor, and we have the integrated circuit with the three vendors, here, and this is the formula item. If we go to the engineering lines, here we can see the plan groups. So the plan group here is used to group the alternative components from the three vendors, and this is the priority. So if there is no availability, the system will suggest me to purchase the first item. If I have availability on hand, the system will first consume those quantities and then suggest me to purchase from the vendor, from, I believe is ST. So if we go to the sales order, Yeah. Okay. Okay, I prepare a sales order, number 8. And for, let me change the quantity. For 100 pieces. Okay. And if we go to product and supply, and then explosion, and we update. Okay. In our example, I had 20 pieces on hand for the component, the integrated circuit from Samsung. So the system will suggest me to use those quantities. And then on the last line, we have the suggestion to purchase the highest in priority, so number 30. Okay, I'll switch back. Yeah. Okay. So that's, yeah, we move on. So the second issue we addressed using process manufacturing is the co-product management. In this case, we have a motherboard. So from the production point of view, we produce a motherboard, then we cut it into pieces, and we have these co-products. And so we find that using process manufacturing, we can have a solution to this problem.
I think this was pretty unique when I saw this for the first time, that it's a completely discrete environment, and nobody would ideally... Hello? Yeah, so nobody would ideally think of using process manufacturing capability in a very discrete environment. But the point is that you just have to look at all the functionality that is available in AX and not think about, not name the functionality as such that this is only used for process manufacturing, right? So that's why I asked Roberto and Diego to come here and demonstrate this, because it's a motherboard, right? And usually you won't think of a motherboard being divided into 4 pieces as co-products of a process. So that's I think it was very powerful.
Yeah. Okay, here we have the product designer creating products, creating a planning item, which is the motherboard, and all the co-product items. And then we have the formula for the motherboard, and we have also the co-product formula, let me say. Then when we go through the process, we arrive to the batch order created. And here I will show you in the next demo how the report is finished works for co-products. So this is only an explanation of what I said. Yeah. Okay. Okay. We go back to the, products. This is the motherboard item, and the planning type is planning item, as you can see. And we have is 3 co-products here. So always looking at the production type column. And if we look at the formula lines, so engineer lines, here we have the list of components that has to be used to produce the motherboard, and also the list of co-products linked to this motherboard. So the production process, as I said before, is from the production point of view, creating a motherboard. From a sales point of view, we are going to sell a single co-product. So in my example, I had a sales order, number 7, a sales order for the co-product. one of the 3 co-products and for 100 pieces. And the system will suggest me to produce an entire motherboard. Yeah. So if I go to the explosion, the system simply is suggesting me to create a batch order for 100 pieces. If we go to the planning order, planned order, sorry, and search for the one created by the explosion, we saw that the item number that is going to be produced is the motherboard and not the co-product, obviously. So now I'm going to defer the batch order, and then I go back to the production batch order. Yeah. Okay. This is my production batch order, and for the motherboard. And yeah, the formula.
Oh, just the co-production.
Okay, this is the formula, so we can have a look to the components that are going to be picked and consumed, and also the co-products, the 3 co-products. And this is the one that is going to cover the requirement from the sales order. And in the quantity tab, we have the estimated quantity for each line and the remaining quantity for each line. Right now, I'm going to report as finished. And if we go back to the products, products, okay, we can see that the motherboard has no transaction. It's only used for planning purposes, while the co-product, all the 3 co-products, has a receipt transaction. So 1, 2, and 3.
Okay.
Okay. You need my microphone?
No, that's fine.
Hello. Okay, so just to quickly wrap up. So basically what you can do with this release is that you can use manufacturing execution with process manufacturing, and you can be in control of your own formulas using block editing, using block removal of approval or e-signature, and you can be in better control of production costs by having more flexibility to do co-product allocation and by-product allocation. Okay, so we hope you enjoyed the session, and if you have any questions, maybe we can ask the question in the next session. So there's